much, everyone, for joining us today for our webinar on changing the game in real-time location systems. I'm Beverly Karkner. I'm the Director of Marketing and Customer Experience at Redlore. And today, Redlore is joined by Wirepass and Accenture. And I'll pass it over to our speakers to introduce themselves in a moment. First, I wanted to, I'm just going to invite a couple people in here that are joining late. To talk about what our agenda is going to be today. We're going to talk about real-time location systems, or RTLS, what RTLS is, the growth of RTLS, and what the advances are. Then we're going to talk about Redlore's Locus solution, how Locus works, how Locus is different, and we'll review Wirepass as the communication backbone and look at performance comparisons. In addition, we're going to look at RTLS in the industry, the genesis and the journey to 4.0. We'll review some use cases from various industries, and then we'll have about 10 minutes before the Q&A, before wrapping up right at 12. So just so you're aware, the participants' mics have been muted to prevent ambient noise during the webinar, but we encourage you to please post any questions you have in the chat or message me directly, and then we can address them during the Q&A session. So I'd like to pass it over to our speakers today to introduce themselves. Please go ahead, Nick.
Thank you, Bev. Hello, everyone, and thank you for joining us at this webinar. My name is Nick van Eerdenk. I'm the CEO and founder of Redlore. I'm very excited that you guys were interested to join us at this webinar, and we really hope we're going to make it worth your while by giving you a mix of a dive into the technology, the position of Redlore in the world of RTLS. And I'm also honored that we have two distinguished speakers who accepted to help us set up this webinar. Brett, who is now with Wirepass, was active in the RTLS industry from its very early foundational days in the early 2000s. So Brett knows, has seen all of RTLS and has a very broad view on what's going on. And then also Fadi Mahmood, who is with Accenture, who I think we can consider a thought leader in this industry, and who I'm very happy will give his view and share his insights on where the industry is going. At Redlore, we specialize in RTLS. Some people call it on-site location tracking. So we specialize in RTLS and condition monitoring. That's our bread and butter. So in this webinar, we'll share our view on the different types and styles of RTLS, and hope you can find your way in it at the end of the webinar. Handing it over to you, Brett.
Thanks, Nick. I think you've given a good summary. I very much appreciate being invited to the webinar and being able to talk about the way that you guys are enabling technology to really change the game in terms of RTLS, in terms of the economics of deployment, and making more use cases have a positive ROI than had been possible in the past. Fadi?
Thanks, Brett. Thanks, Nick. Fadi Mahmood, Senior Director at Accenture. Been roughly at Accenture about 5 years, been in the industry 32 years. Worked in all the way from embedded systems all the way to cloud and network storage, and the embedded systems, it was where it got me to RTLS and so many other technologies. I'm ex-Adaptec, Microsoft, Dell, 24 patents. I love technology, and I'm happy to be here to share some of the insights that we know about RTLS. Thank you.
Great, and Pat?
Sure. Hi, everyone. My name is Pat Teneriello, and I'm our VP of Business Development here at Redlore. Very excited to be on this webinar. And my journey, in my role at Redlore, I work very closely with our customers to implement RTLS technology and help them solve pain points in their operations and their supply chains. And so I'll be sharing a few use cases with you and looking forward to this discussion.
Great, and if you'd like to go ahead with RTLS, Pat?
Sure. So I'm going to quickly just kind of frame today's webinar. As Nick alluded to, RTLS is it really is all about tracking assets for location and also for condition. And for the purposes of this webinar, what we're really going to be talking about is tracking within the four walls of a facility. So what we refer to at Redlore as on-site asset tracking. So when we think about location, usually that's two things. It could be an asset that's in a state that it's at a location, or it could be that it's in transit. So it's moving from one location to the other, from point A to point B, and that's also considered RTLS. But for the purposes of this webinar, we're really going to be talking about those assets which are in a state where they're on site, they're either in the four walls, or they're at a lay yard, or just on the outside of a facility, and we're tracking them for where they're located at that facility, and also what condition they're in. So when we talk about condition, what that means is really telematics. So it could be the temperature and the humidity of the asset. It could be detecting motion of that asset, or vibration, a shock, an impact, tilt, or the orientation of that asset. It could be detecting light or sound around that asset, or volatile organic compounds. So when we talk about condition, we mean telematics like that. When we talk about the word assets, that could be really a number of things. Typically, when I talk to customers, that's tracking their products, their inventory, their SKUs. It can also mean tracking the reusable assets where these products sit. So that could be reusable pallets or totes or containers. It can also be capital equipment or machines that sit at the site. So that could be forklifts or scissor lifts or welding machines. And also it can also be people assets. So tracking for staff or for patients. And so that's really what we mean when we talk about assets. And the last thing I'll say here is when we think of RTLS, we think about tracking the assets for location, but it can also mean tracking processes for those assets. So typically, if you're talking about a manufacturing facility or warehouse or distribution center, there's steps that occur in the life of that asset while it's at the facility. And today, most customers are tracking the process, the assets process with a handheld RF gun. And really with RTLS, you can unlock a lot of value by automating and eliminating the need for that manual process. So in summary, what is RTLS? It's tracking any asset and process, and for the sake of this conversation, within a facility. So both indoor and outside the facility. I'll pass it over to Nick, I believe.
Thanks, Pat. So in the next couple of slides, I'd like to share some numbers with you about the size of this market, RTLS, because we get asked by customers a lot. So is now the time to engage? We see some applications where RTLS could be of value. Is the technology mature enough yet? Is it still in its infancy? So I'd like to speak to that a little bit. I think for the people who have been involved in RTLS in the early days, we're talking about the end of the 1990s, the early 2000s. So that's where the foundational technologies really were born. And on this slide, you can see some numbers that were compiled by a market research company, Allied Market Research, where they've tracked the RTLS market size in the past and extrapolated that into the future. And when we speak about RTLS, or at least in their definition of RTLS, they include everything ranging from RFID that you could see as the low end in RTLS, all the way up to ultra wideband UWB, which is at the high end. So everything's comprised within there. And today we see that the total value worldwide of that market is roughly $4 billion. And that is supposed to grow by a factor of 10 in the next 10 years. So the question we should ask ourselves is that a proof of maturity? Where is this technology in its maturity cycle? So let's break it down a little bit. A growth of a factor of 10 in 10 years means a 27% year-over-year growth, compound annual growth rate. That is a lot. That is a type of growth that you see when a technology is maturing, is coming out of the innovation stage and is going into large-scale deployments. To speak to that number a little bit, by comparing it to another markets, the electrical vehicle market, the EV market. So in the same time period, the EV market will grow by 25% year on year. So that's about the same growth rate as we're seeing with RTLS. And another comparison I like to draw is, so now this market is at 4 billion, will grow to about 40 billion in 10 years time. So what other market is worth $40 billion? Well, the industrial robotics market today is worth about $40 billion. And I think a lot of people, probably a lot of people on this call can understand, are from the industry and understand that industrial robotics is a mature and a big industry. So that's what we can compare RTLS with. And the next slide, please. And where are we at Redlor? Where do we see this growth driven from? What are the drivers? And we see basically two things that are coming together. We see a stronger demand pool from the market, and at the same time we see, and we're very active in this ourselves, of course, is that technology is really making a push. So let's break that down. First, the demand side pull. What is strongly driving the adoption and has been in the last has increased, has been amplified in the last 2-3 years, is that our supply chains have been strained. This is an open door, of course, everybody knows this. But the fact that our supply chains are saturated, that our logistics assets, our ships, our trucks drivers, our warehouses are all oversaturated, combined with the fact that we cannot expand capacity of these logistics assets just from one day to the next, is leading industrial players who are operating in supply chain businesses or who have very heavy supply chains. So these two facts are driving these companies to become more efficient with the assets they have. And when we talk about efficiency increase, we talk about technology, and that's where RTLS has a lot to offer. And we'll go into detail more when we talk about use cases. Efficiency, or the need for efficiency increase, is also driven by is also driving the adoption of RTLS in a number of other ways. When people talk about efficiencies, they talk about uncovering these efficiencies by the use of business analytics, to run analytics, to analyze where efficiencies can be found. And in order to run these business analytics, you need the data, you need the raw data, and that's where RTLS comes in, and that's also where condition monitoring comes in. A few other aspects that are related to efficiency is to reduce the reliance on human activity, which is by nature error prone. Humans, for example, use a barcode scanning process to move goods along in the supply chain, to move them from reception into production, into et cetera, et cetera. And that's where RTLS, by tracking the location of where are things, can remove that barcode scanning process for a large part and get rid of that human error part. And then an interesting element that we also see is that that is also fueling the growth of RTLS is coming from the consumer side of things. There is a proliferation of smart devices. Think of the Apple AirTag that you can just drop into any container, any box, and you can follow it along where it's going in the world. And this has, even if this is on the consumer side, and at Redlor we're very much and RTLS is very much at the industrial side, at least within the scope of what we're talking about at this webinar. We see that there's a lot of awareness creation coming from from these smart devices, these smart trackers. On the technology push side, there's also a lot happening. First of all, we're able to achieve much higher accuracies in positioning accuracy than we used to. And a higher accuracy is not just better than a lower accuracy. It's actually, the accuracy needs to be good enough to solve the use case. If you need 1 meter accuracy to solve the use case, then anything better than that will not be of much help. So you're not willing to pay for higher accuracy. But if you can't reach the 1 meter accuracy and you need it for your use case, then the technology is not an answer to your use case. So what this means is that the fact that newer technologies bring us higher accuracy opens up a whole new breadth of use cases that were previously out of reach. Another few elements coming from the technology is that there is price erosion on technology, which we as technology providers may not always like, but the truth of it is that when prices go down, new use cases become economically viable, so it makes sense for all. And then also, as the technology is maturing, it's become easier to install, easier to deploy, and the user experience is better, which also helps a lot. So that summarizes my high-level economic overview of where this technology fits into its growth and adoption cycle. What I'd like to do now is to do a dive into the technology of RTLS and give you some insights in how it works. We get a lot of questions on this. We educate a lot of our customers on this. Within the next 3 minutes, I won't have the time to be exhaustive, nor to go really into the science of it, but I hope it will give you an overview of how things work. So on this first slide, we're talking about how we actually detect where something is. And there's two basic algorithms, two basic mechanisms that I'd like to mention. One is proximity. So in proximity, what you basically do is you detect that tag, which is attached to the asset you want to track. So we call that a tag, a little electronic device. When that tag is in reach of the anchor device, then it is detected as being at that anchor device. Now let's define the word anchor for a moment. Some people call it a reader, other people call it base stations, access points. So we'll call it anchor for in the scope of this webinar. An anchor is a device that is attached to your infrastructure. It's attached to the wall, to the ceiling, to a rack. It can be outdoor on a post. So it's part of your infrastructure, and it communicates wirelessly with the tags. So anchors and tags in proximity, the anchor tries to find all the tags that it can see within a certain distance. There's several technologies that are capable of supporting proximity-based detection. One is RFID. We'll talk more about RFID later. Bluetooth, Wi-Fi, also WirePass. Brett's going to talk more about WirePass later. Just know that Redlore Locus is built on top of WirePass. Locus is the name of the Redlore solution, built on top of WirePass. For completeness, I've also added ultra-wideband here, although ultra-wideband is usually not used just for proximity. And then there's some other technologies, ultrasonic infrared, that can be used for proximity detection, but they're sort of less. They're going to be less fueling the growth in RTLS. Let's now move on to the right side of this slide. Let's talk about multilateration, multi-angulation, sometimes called trilateration if you only use 3 anchors, or triangulation. So the detection, how the detection works of the location is as follows. So have a look at that little sketch at the bottom right of this slide. You see a tag in blue, and then you see 3 anchors spread out, anchor 1, anchor 2, anchor 3 at the bottom in red. So what you basically do in multilateration is that you figure out what the distance is between the tag and its nearby anchors. If the distance is, for example, 10 meters, 33 feet, then you know that that tag is somewhere on a circle 33 feet, 10 meters away from that anchor. So you draw a circle around that anchor. and you do the same for a couple of other anchors. And where those circles intersect, that's where you know your tag is. So that's how it works, and we'll talk about the pros and cons in a minute. The technologies that use triangulation or that underlie multilateration, trilateration are Bluetooth and Wi-Fi, Wirepass again, and hence also Redlore Locus, which is built on top of Wirepass, and also ultra wideband. And ultra wideband is also a component of the Redlore Locus solution. Just for clarity, GPS is also a multilateration example. It uses the same algorithmic principles. GPS is outside of the scope of RTLS, where we won't consider it here, but just as an interesting fact. Next slide, please. So we saw in the previous slide that determining the distance between an anchor and a tag is the basic ingredient for multilateration to work. So how can we determine that distance? Well, there's two basic ways. There's more, but there's two important ones to note here. One is based on signal strength. So have a look at that little sketch at the left side of your slide. Let's assume that our anchor in red is transmitting a wireless signal with a strength of 10. And let's assume that that message is received by the tag in blue with a strength of 4. Obviously, it's weaker because the message will weaken as it propagates through the air. So that signal lost strength, in this case by 6. 10 minus 4 is 6. And there's physics around this. There's basically a curve where you can look up if the signal degraded by 6, then it traveled a certain distance. In this example, 10 meters. So that's the principle. Now, the accuracy of signal strength based distance estimation is relatively low. It's 2 to 5 meters error that you have on average. And the reason is that this relationship between weakening of the signal strength and distance is based on a certain medium, air typically. The signal is traveling through air, so if it weakens that much, then it traveled that distance, 10 meters through air. In reality, in our environments, we have air, we also have concrete, we have wood, we have people, which is basically a lot of water-like content, and wireless signals typically weaken a lot when they pass through that sort of materials, meaning that there is a distortion of your distance estimation. The pro of this principle of distance estimation, signal strength, the big pro is that it's very low cost, because from the moment that you have a transmitter and a receiver, you get this for free basically. So it's a free add-on to having something that transmits and receives. So that's signal strength. Some people call it RSSI as well. You may have heard this. I use the word signal strength. I think it's more applicable to what it really is. RSSI stands for Received Signal Strength Indication, which the engineers like to use. The second principle, moving to the right side of the screen, is time of flight based. So have a look at this sketch right below the title. So there you can see that the anchor in red transmits a message at time 0, and this message is received by the blue tag at time 33 nanoseconds, 33 billionths of a second. So it traveled for 33 nanoseconds, and that equates to 10 meters again. So the principle is that you measure how long it took the signal to travel, and you know that the signal travels at the speed of light, so you know how far it traveled for. The big advantage of time of flight is that it's very accurate. It's roughly half a meter, 1.5 foot, although it can be even much better than that. Can go down to 1/3 of that, to just 15 centimeters. And the reason is that the speed of light varies less when it goes through different mediums than the signal strength would. So it's highly accurate. It does add a cost. It has a cost disadvantage because you need a UWB and ultra wideband chipset. So the technology, the most well-known popular technology that uses time of flight is ultra wideband. I'm sure many of you have heard of it. And Locus High Res, so the Redlore solution, it uses ultra wideband on top of Wirepass to do its job. There's a slightly higher cost to it because of this. There's a higher infrastructure cost usually to it. We'll speak later about how Redlore tackles this to bring that cost back down. Next slide, please. So as a summary, what you can see here on the vertical axis is the cost of the installation, the cost of the technology, both the equipment, the installation, the tags, and on the horizontal axis, you see sort of the accuracy and the performance from left to right, RFID signals at low cost, signal strength RSSI, medium cost, and ultra wideband is a higher cost solution, at least when we speak about the general overview on the market. Okay. So now we'll talk about how the Redlore solution works. Everything we said before was more generic overview that would apply to other vendors of RTLS solutions. Now we're talking about the Redlore solution called Locus, and I'll hand it over to Brett at the end to talk a little bit about the underlying technology, which is Wirepass based. So Locus, how does it work? Well, what you see here is a little sketch of could be a warehouse, and in red you see the anchors again. So the anchors are typically spread out on a grid of 15 meters, 50 feet. And then you have the little blue tags that wander around in the facility. And then you have that black thingy there, which is a cellular gateway. So what really happens is that the network will figure out all these distances that we talked about later. All that data will be routed over the mesh network, the Wirepass mesh network, the red anchors, and will flow to the gateway, and the gateway will send it on to the Redlore IoT platform. Brett will say a lot more about what a mesh network is, so I'll just suffice to say that these are all battery operated devices. There's no wires involved. It's entirely wire free, and you don't need to do any network planning. You don't need to be a network engineer to install this. You just plug them on the wall and they will automatically form a network. All the anchor devices actually act as repeater stations for other anchors that are further away from the gateway. So they will just happily hop messages across this network to the gateway where it should be. So no wires and no installation nightmares. And when your environment changes, they will automatically change your configuration to adapt for new walls that you've built, or maybe you've extended the building. So this is the field level. Next slide, please. We move up to the Redlore IoT platform, which is that brainy cloud gray form that you see on this slide. So that's the Redlore IoT platform. There's a lot to say about this that is outside of the scope of this webinar. So we just highlighted two of the important elements that are relevant on this topic, which is one, the positioning engine. The positioning engine receives from the gateway the tag to anchor distances, and it will do all those calculations that we talked about before. So the trilateration, the multilateration is done in there. But it's more than that, because the positioning engine also receives floor plans. So the fact that it has floor plans means that it can generate alerts. When something is moving from one room into another room, you may want to know that. It can create an event, it can create an alert. So it adds a level of intelligence on top of the pure XY position. And one other element, we talked about condition monitoring. Pat introduced the word telemetry, which is basically sensor data. So the raw sensor data is also coming from the gateways, flowing into this telemetry engine. And the telemetry engine can do all sorts of manipulations with that data. It can send out alerts when certain thresholds, for example, temperature excursions have occurred. So this platform works works with both flavors of Locus. So there are two flavors of Locus. One is using signal strength based distance determination. So it has that 2 to 5 meters accuracy. We call it Locus Standard Res. And then we also have the ultra wideband version of Locus, which is Locus High Res, which gets you down to 15 to 50 centimeters. So that's half a foot to 1.5 foot of accuracy. So the IoT platform works with both, and you can even use both in the same environment. You can equip half of your warehouse with high res, the other half with standard res. It will all work nicely together. And the sensors can be part of mobile units where you also track the location, or you can put them at fixed locations, for example, if you're operating a cold storage warehouse. Next slide, please. And then where does that data flow to? So from the Redlore IoT platform, it either goes to the Redlore dashboards. We call that Redboard. That's a platform where you can view all that data, where you can interact with the devices. Or if you have your external IT system, whether it's an ERP, a WMS, or a TMS system, so the data can flow to your own system through an API, or we can send you real-time streaming data over an HTTPS link. So you can combine both if that's the way you want to go. We sometimes get asked the question, so by customers who built their own IoT platform or who have already invested in an external IoT platform, can we use our existing IoT platform? The answer is absolutely yes. So our IoT platform is there to perform the positioning calculations, to do the low-level device management, to do a lot of housekeeping at the IoT level. If you have an IoT platform that takes care of application-related things, then absolutely you can tie the two platforms together. Okay. Now, how is Locus different from other solutions? So how do we, technologically speaking, what is different? So I think Locus is unique in being entirely wire-free and having the capability of doing high accuracy, so the ultra wideband. I think that's where, if that's what's important for you, that high accuracy combined with entirely wire-free, I think that's where Locus thrives. And the reason it can do that is it's wire-free because it uses WirePass as the communication backbone. So there's no data wiring, there's no power wiring, because the anchors will operate for 10 years or more on a single battery charge. And what we see is the reason why customers like this in particular is because it saves them 90% in the installation cost, because pulling wires is an expensive endeavor, and especially if you go into hospital environments or manufacturing environments that are active, that are operating 24/7, then pulling wires is a very onerous experience. So we typically say you can install 100,000 square feet, or roughly 10,000 square meters, in 2 days. And the second important differentiator is that we combine positioning and telemetry in a single network. So it's not just about position; it's also what state are my goods in, and you can combine both. So you can generate an alert, for example, if there's a physical impact in the production zone, as an example. Okay. So to summarize this. The whole point of Locus, and that's where Locus really finds its place in the world, is there where you want to save cost. You don't want to move up that scale from low to medium to high cost when you move from RFID to signal strength based to ultra wideband. But you do need that accuracy, but you cannot, your use case, your application does not support the higher cost point. That's where Locus comes into play, because it's wire-free, because you save installation costs, and because you also save in the cost of the equipment. Okay, over to you, Brett.
Thanks, Nick. So I'm just going to give a very brief overview of kind of the, Nick's talked already about kind of the WirePass enabling capability and what it allows with regards to the solution that Redlore has developed. WirePass is a company founded in 2010, based out of Finland. We're a mature startup. about 70 or 80 employees globally, have a very strong patent portfolio that has to do with kind of the mesh communication that we're going to talk about. And today, about 200 partners around the globe that use our firmware to implement solutions on their hardware and full solutions. Next slide, please. So today we're talking about smart tracking, the portfolio that industries that Wirepass can address with the technology that we've developed is pretty broad, from smart tracking, smart building, smart manufacturing, as well as smart metering. Next slide. We're today obviously talking about smart tracking and smart manufacturing, where we have a lot of partners that develop hardware and develop solutions for indoor tracking, for container tracking, some that we'll be talking about a little bit later in the use cases. But just to show you, there's a pretty broad spectrum in smart building and in smart metering. Some of our largest deployments today are probably 900,000 nodes in a mesh that are part of some of the smart metering implementations that we've done. Next slide, please. So what is it that makes this different? Nick's already alluded to these ease of installation and the fact that there's no wires. That takes both an enormous amount of time and an enormous amount of dollars out of the install. Very low cost to do. It's proven for very large scale. As I mentioned, our largest mesh network is probably over 900,000 nodes. And unlike maybe some of you have been exposed to mesh kinds of networks in the past, there's a BLE mesh, there used to be a Zigbee, I guess still is a Zigbee mesh, which are kind of top-down hierarchical kinds of mesh, which is not what Wirepass is, and one of the reasons that we can accomplish a lot of the goals that I just talked about. So if you go to the next slide, please. Wirepass, just to be clear, doesn't make devices, nor do we make applications. So we kind of sit between the device hardware and the application. Today, that's primarily sub-gigahertz or the BLE frequencies. Soon that will be DEC 2020 and 5G as well. But regardless of the device hardware that it sits on top of, it creates this wireless mesh network that allows multiple single or double gateways to be able to take data from an entire installation and pass it along to our software suite that has a variety of different network tools, a separate optional Wirepass positioning engine, and other cloud tools. So this works in conjunction with the hardware examples at the top. As I mentioned, there are several hundred partners that make hardware, whether it's tags or whether it's the anchors that Nick was talking about, or whether it's a gateway. And then ultimately, at the end of the day, there's a dashboard for people to be able to visualize what the solution is doing that's been Wirepass enabled. Next slide, please. So here's a little bit more detail of kind of what I was talking about with regards to the wireless mesh that we enable. And because we understand the environment in which an individual tag is in, we can operate in either a low latency or a low power mode. And it's very decentralized. So if a single one of these nodes dies, all the nodes automatically recover because they're environmentally aware with regards to what they're transmitting and what they're receiving. It's also secure so that an additional device has to be invited into the network in order to be able to participate. The adaptive transmit power we've already talked about, and it's locally synchronized, so it can provide point-to-point. Devices can also be used as a router, or they can simply be used as a transmitter. And all of that's kind of covered in the organic, environmentally aware kind of mesh network that Wirepass enables. Next slide, please. And I mentioned a variety of different partners. We're going to talk about use cases a little bit later in the presentation, but whether it's warehouses or whether it's condition monitoring, whether it's location inside of a building, whether it's location for containers, we'll talk about some of those use cases a little bit later. But this is just a snapshot of a variety of different things that can be enabled with the Wirepass solution. And next goes back to you, I guess, Nick.
Thanks, Brett. In view of timing, I'll keep this very short, then we have enough time to talk about use cases, which I'm sure you're interested in. We've covered most of this slide. This is a comparison between the different technologies. So let me suffice to just summarize this. RFID is really in a different league, not in a better league or in a worse league, but RFID is a technology that has been developed to replace barcode scanning. Barcode scanning, you go to a place with a gun, you scan it, or you bring the goods to a certain place where there's a built-in scanner. RFID is exactly the same. RFID is not a tracking technology. There's no way where you can outfit a warehouse full of RFID and know at any point in time where things is. So RFID does not allow location tracking, does not allow inventory. And unfortunately, we have several customers who had a negative experience with RFID because it had been sold to them as a tracking technology. So just so that you understand that. Most of what the three technologies on the right do, so Bluetooth Wi-Fi versus ultra wideband versus Locus, which is ultra wideband over wirepass. Most of this we have been said. We've talked about the accuracy. We've talked about the wire-free nature of Locus. One thing we haven't talked about is that one of the advantages of the standard Bluetooth Wi-Fi and ultra wideband over Locus, just to give you the other side of the coin as well, is that ultra wideband can give you very fast update rates, like for forklift collision detection. Locus is not focusing on that sort of very high speed applications. The update rate of Locus is in the order of 10 seconds. Bluetooth Wi-Fi is somewhere in between. So this is important to understand and to match up with your application. And the final thing to note here is that, and we talked about this before, is that the big advantage of Locus over all the other technologies is that its wire-free nature makes it so much easier and more affordable to install. Okay.
Great, and we'll pass it over to Claudia from Accenture.
Thank you, Nick. Thank you, Beverly. Next slide, please. So we're going to look at RTLS, the genesis of RTLS, and how we're going into Industry 4.0. As you see, we started by papyrus, then paper, then ledger, then spreadsheets. The last five, RFID, Wi-Fi, BLE, UWB, mesh, and 5G, are the current art of the technology and state of the technology these days. Of course, in between there is Hall effect also, there's ultrasound and other things as well. But the most prevalent these days is RFID, Wi-Fi, BLE, UWB, mesh, and 5G. Next slide, please. What do we, as an Accenture and as clients, of course, what do we ultimately pursue is mostly it's a business goals. I'm a technologist, but at the end of the day, if the technology doesn't align with the business, there is no need for it. We're looking for efficiencies, return on investment, competitive advantage. The client wants to be ahead of their competitors. Improving revenue streams, reducing cost, and putting the right money in the right investment that is going to scale in the future, not for the sake of the immediate need. The other thing we do at Accenture is Value 360. We look actually at the company as a whole, all the way from talent to sustainability to other things as well, in addition to the main goal of providing a solution for the current problem. But the alignment with the future, the future proofing, the scalability, those are important because we never want to build something for today and then go change it tomorrow. And hence actually some of what Nick had mentioned about, and I've heard it from some of the clients, is give me Bluetooth today on top of wirepass as an example, as a mesh. However, I want to be able to move forward in the future with more accuracy to UWB, and not necessarily it's for the same assets. It could be different assets. It could be high value assets that I want UWB tags on it, but the normal everyday assets that's less of a value, those can be a BLE assets, and for other parameters as well, and reasoning. Next slide, please. So what are the challenges? There are so many technologies out there. And I would say in the last 15 years, we have been fortunately exposed to so many technologies within RTLS and the pieces that connects to RTLS, and we'll see it in the next slide. How do I get the right solution? Because I'm going to invest and I want to do the rightful investment. Which platform? Nick actually mentioned about IoT. Do I use my IoT platform or a new IoT platform or Redlore's platform? Data sources and sensors. So which ones should I check? Which ones I don't care about checking? Security. Absolutely, security has been one of the most important discussions we're always having due to the reasons that you're probably all aware of. Current processes, Nick had mentioned that, and Pat had mentioned that. The ability to readjust your processes as a client to adapt to the new technology. And actually, Pat earlier gave an example of that. Reskilling. Once you introduce a new technology, introduce new processes, there is a training process that's going to have to happen to the to your personnel. Infrastructure. Nick had mentioned that a couple times. We will talk about that in the next slide. Absolutely important. It's a business killer. It's a project killer, and we'll talk about that in a minute. Brownfields integration. Clients have ERP already. Clients have WMS. The clients already have system that they run with and they want to keep. And you want to be able to integrate into these systems seamlessly, real time as well. Scalability, we talked about it. Modularity. In some cases, you have clients that want entering into a specific area within your software stack. They probably don't want the UI or the presentation on your side that you provide as a partner. So the modularity and the layering of your stack is absolutely important. And this is how we build it to make sure that it is modular and flexible. Next slide, please. Here are the parameters to solution. And those I would say about 60-70% of what we look at for RTLS. There are a lot of other parameters, but I didn't want to jam it over here, and it's already a lot. Real-time visibility, absolutely important. I want to know exactly where things are, where it's heading, who has it, if possible. It's another layer of solutioning. Cost, absolutely. Cost is one of the reasoning why some of the clients actually hold back on implementing some of those solutions. Power to the devices. This one of the things that I believe Redlore has an advantage. The ability to run on battery, the ability to be completely independent of running any cabling. You'll see cabling in one of the lists in the middle. This is actually, and I want to take moments here just to say that in some discussions with clients, we had with them, cabling was the area that they decided not to pursue the project. So I don't want to run cabling. I don't want to deal with cabling. I don't want to take the cost of cabling. I don't have people to do cabling for me, so I have to hire others. So there are so many reasons that cabling end up to be the reason to not do the project and pursue and improving your efficiencies as a client. And hence, you have to figure out different ways. You have to figure out already an electrical infrastructure that you can connect to, or battery-based that is actually going to run for multiple years. I'm not going to go through all of those, but I'm highlighting some of the aspects. Reliability and redundancy is absolutely important. Brett had mentioned that as an example of the wire pass ability to reform itself and making sure that the messages are continued to flow, although maybe you have one of your devices is down, one of your anchors are down. You want to look at your environment. Nick had mentioned that earlier. Is it metal? Is it liquid? How many people are around? Because people are almost like liquid. The reflections does affect the accuracy. Other things we look at is what is the SLA and support that the client is going to get after a system has been done. Scalability and growth we talked about, and there are cases where clients want to run the solution on-prem. They don't want to have anything on the cloud. And there are other things that also important. Control tower as an example. Control tower is more than just real-time visibility. It's about aggregating all data from everywhere, including one of them is RTLS, and have a holistic view of all my manufacturing system, warehouse, hospital. I see it in one place. I see all the alerts, actions, and so forth. Next slide, please. So if as a client, if you feel lonely, you're not alone. In manufacturing, as an example, 82% believe flexibility is critical. 60% of the capacity of the equipment has not been used, and 1.8x is the cost to repair failed assets because I have no visibility. So you see, visibility and real-time visibility and actions on this visibility, taken actions, can reduce cost, can improve efficiency. And when we do that, then as a client, you're producing more, which hence increasing your revenue, hence you can invest back and grow. Next slide, please. Let's take a quick example here in the healthcare provider. Their challenge is lost equipment, wrong equipment in the wrong place, outdated spreadsheets, believe it or not. In some cases, they use spreadsheets. Believe it or not, in some cases, they use papers. Today, unknown asset usage, unknown asset condition, unknown location, the staff is overloaded. Those are nurses. You want the nurses to be with the patient, not looking for an equipment or looking for a connection that they didn't know that would work. Transparency from a business perspective, integration to system ROI. I know we're very tight on time, and the approach we did is we did design thinking. We sat with the nurses, with the staff, with doctors, with the asset management team. We applied the RTLS aspects, as I mentioned earlier, and we find the solution is a combination between BLE and UW RTLS with machine learning to do predictive analytics. We ended up reducing cost, roughly about 500K, 150K, recapturing revenue due to higher efficiencies. Essentially, they became so efficient that they were able to see more patients and hence make more money rather than sending patients to the next hospital within the neighborhood. And roughly the ROI was about 260% on a balance sheet basis and about 60% on a cash flow basis. That's a huge ROI. Next, please. I think I'm handing it to Brett.
Great, thanks, Fadi. I appreciate it. So just briefly, we've already kind of talked about smart tracking and the advantages of no wires, fully operated, low capital costs with regards to deployment and low operating costs. So I'm just going to walk through 4 or 5 quickly deployed customers. The first of these is Maersk, very large shipping company, very challenging metal environment. Deployed the WirePath solution, and the solution is also now part of the Digital Container Shipping Association, or the DCSA, for being able to do this sort of technology assessment of location and presence on board ships. Next slide. Prologis warehouses we talked about before. Very large spaces traditionally have been kind of not viable for asset tracking or for condition monitoring, just because of the sheer size and the number of receivers required. Now the wire pass enabled solution is kind of a standard for Prologis in places where they're going to keep track proactively of location of goods, location of pallets, as well as lighting control and energy saving with condition monitoring. Next slide, please. Worker safety, as we talked about, this particular partner, WakeCap, has integrated the wire pass technology into a tag that is physically integrated into the helmet itself. So all workers are required to have their helmet when on site, knowing where workers are for lone worker situations or from a safety concern. Again, using a minimal kind of infrastructure in order to enable it has meant some very good business for the WakeCap partner. Next slide, please. Fujitsu, we've already talked about healthcare. Healthcare, probably one of the original mainstream RTLS applications. Large ROI, but kind of stuck at the 20 or 30% adoption rate, at least in the US, with the WirePass enabled infrastructure being able to reduce that capital cost, which is the primary reason that a lot of hospitals don't deploy, enables asset tracking, indoor navigation, sensing, lighting control, all those things that we've talked about before with minimizing the amount of wires required and minimizing the upfront capital cost. Next slide. And finally, automotive manufacturing. Automotive manufacturers today basically assemble from sub-assemblies. So keeping track of where those sub-assemblies are when they actually get to the plant or whether they're still at the subcontractor is an application that Internav, our partner, has been able to implement. Again, the same kind of theme that we talked about, very fast installation on an 18,000 square meter facility, being able to keep track of where those sub-assemblies are and even keeping where the car is after the wheels are on and it's no longer on a linear flow. Next slide. I think it goes over to Pat.
Yes. In light of time, should we sneak in a question if someone has, or before I jump into, I have two use cases. Maybe I'll get to one, but if there's any questions, maybe now's a good time. Someone wants to jump in.
I think you can go ahead, Pat. I think we can get to the use cases and then wrap up and address any questions kind of post webinar.
Got it. So this is a customer of Redlor's, and we are helping them track their vendor managed inventory. So these guys are a large manufacturer of machines for the paper and pulp industry, and there are inventory that are used in these machines that sit at their customer sites in these cabinets that you see on the right, and we're helping this customer to make sure that when their customers need one of these tools, that the cabinet isn't empty, and we do so they can track the inventory remotely. They can get alerted and they can replenish the cabinet so that the customer never is empty-handed when they need one of these tools. And they're saving labor costs from not having to send auditors into the field to the customer sites to manually count and make sure that there's inventory in these cabinets. Next slide. This customer is a forensic evidence lab, and they work with the National Police Force for very sensitive assets like firearms and evidence for forensic evidence. And they had a problem where they had misplaced a firearm, and they had an antiquated way of tracking for chain of custody. These firearms, they get tested, they get moved around in the lab, and they needed a robust system to know where these assets are at all times, and if someone is using them or testing them, that they have a chain of custody, they have a record of who checked it in and checked it out. And so we're helping to implement that solution. And that's it for me.
Great. So thank you so much. We're at the end of our time today. So I want to thank everybody for joining us today, and let you know that we will be sending out a copy of the webinar. And if you have any additional questions, please feel free to reach out to us, and we would love to chat with you a little bit more about any questions you have or the solutions or any of the information that was presented today. So thank you again, and we really appreciate you joining us today.